Using ratios to compare volumes. A, if two cubes have sides in the ratio of 4 to 6, that means the length of their sides are 4 to 6. What is the ratio of the respective volumes? And B, if two similar cylinders have heights in the ratio C to D, what is the ratio of the respective volumes? So what we would like to do is to compare their volumes without using a volume formula, just using their ratios. And it's done very straightforward. So we have a ratio of 4 to 6, and this is the side ratio. That means the length of the sides from one cube to the other is 4 to 6. That's the way they compare. So if you were to want to compare their areas of the faces of those cubes, it would be 4 to the second to 6 to the second. That's if you're going to compare areas. In our case, they want to compare volumes, so it's to the third power. Notice the ratio, 4 to 6, 4 to 6, 4 to 6. If you're comparing lengths, it's a ratio 4 to 6. If you're comparing areas, raise that ratio, each of these numbers, to the second power. If you're comparing volumes, raise that ratio, each of these numbers, to the third power. So for our problem, if the ratio is 4 to 6, the side ratio, then their volumes would compare the following way. 4 to the third is 64. 6 to the third is 216. You always simplify ratios. So it gives us 8 to 27. That means their volumes compare this way, 8 to 27. Notice we didn't have to use a volume formula doing it with this way, having a ratio already available. B, well, they're not going to commit to a number. They're going to say some length compared to some length. Well, this just reinforces what we just said. If you're going to compare volumes, raise each of these numbers in the ratio to the third power. So the formula would look like this.